Good morning, everyone. This is Shauna, the embedded tutor for your Math 112. I got some questions from some students regarding the first homework, so I wanted to go over some specifics from that for you now. Let me share my screen at this time and bring up the homework assignment in question. So this is your first homework assignment. This is 1.1. The first few questions are directly from the slides, and there is enough information to answer most of these. However, there are a few that were not there. So the first question defines statistics. Okay. What is a variable? Question 2, and question 3, what is meant by a census? So let me show you something here. Let me take you to the slide over here. Let me share this screen. Let me scroll down. And let me show you the slide. So here is your definition of statistics right here. Statistics consists of conducting studies to collect, organize, summarize, analyze, and draw conclusions, specifically from data, okay? So it could be the process of, or the study of, if you want. But that's the definition of statistics, okay? Probability you have there. Let me show you where the definite, we'll come back to this next part in a minute. But a variable is on slide 8. The definition of a variable is right here. A variable is a characteristic that can assume different values. You can have different kinds of variables. We have qualitative, or sometimes we call those categorical variables. You may have heard, if you've had a statistics class before, or you've had some exposure to that, categorical and qualitative are the same term. Or we can have numerical, or what's called quantitative with an N, quantitative data. That gets more into 1.2, but that is part of what's going on here. So there are examples of variables for you there. Also, let's go back to this. What is meant by a census? Now, again, that's another definition that's in your slide. So let me show you where that's at. So the census deals with what we call the difference between a population and a sample. A census is different. So let me show you that. So here on page 6 of the definitions, which is slide 12, it gives you the definition of all three. A population consists of all subjects, human or otherwise, that are being studied, okay? So let's say that I'm a researcher, right? And I want to study the average age of college students in 2023 versus the average age of college students back in 2020, before, right when the pandemic happened. Let's just say that. And let's say that for the sake of example, my population is the set of college students in all California community colleges. I'm specifically studying college students in California. That would be my population. So as part of this study, I go to each of the colleges, and how I study it and how I draw the sample is a little bit, we're going to talk a little bit about that, but that goes into research methods, and that's actually a little bit beyond the scope of this course. But for those of you who might be in psychology or sociology, you'll probably have a class in that called research methods, and they'll go over that in more detail. We will talk about it some. But anyway, back to my example. If my population is all students who are in community college in California or college in California, and I then go to each college and I take from each one a certain number of people, say 50 people from each. That would be my sample. Now, my sample can be small, it can be large, depends on how large my population is. Okay, so that's the difference. Usually a sample is smaller than the population, almost always, because if it was the same size, you might as well sample the whole population. Okay? A census, though, you might have heard of the census. It happens every 10 years. That's our most famous sort of concept of a census. But it's a count for official purposes, for the government, for the city, whatever it might be. And it's the number of people that live in a country, and that you collect demographic information. How many are in each specific demographic category: ethnic group, religious group, residential zone, income level, what kind of socioeconomic status you might have, all kinds of demographic and classification information that you get from a census. That's what a census is. Okay, so hope that clears that up. Let me continue here. Now, how does a population differ from a sample? Number 4. Well, a population generally is larger, first of all, but a population is everybody or every object, because you can study objects or animals as well as people. Okay, so just so you know that I could be a tree surgeon, and I could want to go into a certain area, maybe a national forest, and check the health of the trees. Well, obviously I can't check every tree, so I'm going to take a sample. So those things are more than just people, just so you're aware of that. So populations generally are larger, and as I said, populations include all of the objects or people under study. Samples are a subgroup of that. So how are they different? They're smaller, and populations are the entire group. Explain the difference between descriptive and inferential statistics. And this leads into the questions down below, 9 through 25. So we'll talk about that. Let me go back to the slides at this time and show you something there. So here is where we left off. And we have some examples down below. Now here's descriptive versus inferential statistics. Okay. Now remember, if you remember the definition of statistics, the first part said collecting or collection, organizing, summarizing, and presenting data. That's all descriptive statistics. So that tends to be, if I were to ask you what statistics is or what you think of, people usually say something like, I think of charts, I think of graphs, I think of presentations, maybe tables that you see in your book. Those are all descriptive measures. Valid, perfectly useful, and important, but they're descriptive statistics. So if you have seen sales presentations. Maybe you're a nurse, maybe you're in healthcare, whatever your field or your projected field is. If you've seen graphs or charts or pie charts or something like that, that's descriptive statistics. Inferential statistics is when you take, if you go back to my example from earlier, so I want to study the average age of college students in college now compared to 3 years ago. So I gather data from my sample. Data doesn't just fall out of the sky. There's processes of actually gathering data, whether that's from the school records, whether I go out and ask people, whether I hire people to go and call people for me, whatever the method is, I have to gather those data, okay? And once I gather those data, I have to do a lot of calculations and number crunching and analysis of it. And that usually takes place with big computers, okay? We're gonna learn about how to do this. Inferential statistics is the second part of the course. So when we get to chapter 7, chapter 8 primarily, but there's some in chapter 7 as well. So when we get to the second half of the course, we'll be dealing with inferential statistics. But we number crunch the data, and then we draw some conclusions. If my statement happens to be, I think that students now are younger than students used to be, that would be what we call hypothesis testing. I have a belief that I already believe. I believe students are younger now than before, okay? And I'm going to do a bunch of calculations with my data to find that out. That's inferential. Also, inferential statistics makes predictions about what could happen. It could be that this drug is more effective than that drug, or sometimes it's relationships among variables. Things that you might have heard would be stuff like playing violent video games causes people to become more violent as they get older. That's an old debate. There's evidence on both sides of it, but that's an inferential kind of thing. So that's what inferential statistics does. I hope that clears that up and gives you a little bit more insight into that. She gives you some examples down here on slide number 15. The average age of the students in your math class is 20 years. Now, is this trying to test some sort of belief, determine a relationship, or make a prediction? No, it's just giving me an average. So it's collecting data. That's all it's doing here. Descriptive statistics is that one. Here's an example of an inferential statistic. The chance of you being robbed next year are 12 out of 100. That's making a sort of prediction or creating a statement. There's a chance that I'm going to be robbed, right? It's not telling me how many people or what percentage of people were actually robbed. It's saying you could be. So it's an inference. It's drawing a conclusion about something. Okay. And then there's an example of descriptive versus inferential down here. Here's another descriptive statement. During the Thanksgiving weekend last year, 73 people died in traffic accidents in New York. That's descriptive. Okay. Again, it's telling me how many people died. It's not making a prediction of any sort or creating a relationship. All right. So let me go back now to that was a little bit ahead, but let me come back now to these three questions. Two areas where probability is used. Why is information obtained from samples used more often than information from populations? And what is meant by a biased sample? These actually come from the textbook. And let me show you where they are. I'm going to, let me see. I'm gonna stop sharing for a moment here and bring up something else so I can share this with you. So here is the textbook. Let me also bring this down so that I can make this larger. Where is my view? Okay. It's not letting me. Interesting. Don't know why, but it's not letting me blow this up, so I will just read this to you. On page 3, there is more information about each of the definitions that I just gave you. But in terms of where this is used, okay, it talks about how you can use it in this is where I would use descriptive and inferential statistics. If you go back to the introduction on page 2, it tells you some instances where it says, page 2 says, statistics is used in almost all fields of human endeavor. You can pick a couple of these. Sports uses statistics, things like baseball, football, almost any sport will keep statistics. How many points a person scores, things like that. Sports is a very common place to use statistics. So is education. We talk about things like your GPA, your number of credits that you took. We talk about your class rank or your position, your test scores, right? Those are all statistical data. So sports, education, you can use them in healthcare. Things like, think about the last time if you have children or nieces or nephews, you take them to the doctor, you take them to the pediatrician, right? Or even older folks, like you take them and they monitor things like their blood pressure, their blood sugar, their respirations. Those are all, so education, medicine, sports, anything that you can think of probably will use statistics. But those are 3 that I can think of, but they're here. They're in this paragraph on page 2 of your textbook. Don't need the book, but like I said, for something like this, occasionally, we do have information that's not directly in the slides. So this is where that might be. I'm going to also show you here. Let me go back to let me stop sharing this for a moment here. Oh, before I leave that, let me show you where the population versus the sample is. If you go to the next page on here, it says, hold on. I'm gonna have to move this. Give me a second. Let me just come over here, come down here, and we'll scroll. There it is. Okay, so here is the why do we use a sample versus a population? So here is your answer. And again, you might be able to take this in. Well, if you're going to sample in quotes, the entire population, that's a lot of money to do that. Populations are usually large. So there's a lot of time involved. There's a lot of money usually involved in that. Also, it could be things like, especially if you're studying people in medicine or with certain conditions, there could be medical concerns involved. There could be concerns about privacy. So we don't use the entire population. We don't use the entire group. That's why we sample in the first place. That's on page 3 of your textbook. And again, not in the slides. So that's why I'm going over it. Also, there was one other question about biased sampling. And this is actually something that when you get into research methods that I mentioned earlier, this becomes really important. So you're going to learn, and we're going to talk a little bit more about it, not too much. But essentially, when you draw samples, if you think about my example from earlier, wanting to study all of the students at California community colleges throughout the pandemic, we want our sample to be like a mirror of our population. What I mean by that is this: I don't have the time, the money, the manpower to go and study every single person, right? So I have to draw a sample. Well, that sample should be reflective of the entire population, right? It should give me a picture of what the entire population looks like. If I go look in a mirror and I only see half my face, there could be something missing on the other side, or something that I have on my face and I wouldn't know, right? Or if I have a dirty mirror or a mirror that's cracked, I'm not going to get a proper representation of what this really looks like. And so when I draw a sample from the population, I want my sample to be reflective. We call it representative. We want our sample to be a representative sample of the population. The better my sample represents the population, the more accurate my conclusions can be. Okay. And again, how we draw the sample is a little bit beyond the scope of this course. We do talk about it some in the next couple of sections, but it's not a main focus. When you get to research methods, if you get there, if your major is such that you take another class, you'll learn more about actually how to do that. But why do we use a sample? Because it's less expensive and less time consuming. what does it mean to be biased? Well, if it's not representative, then it's biased. It's showing me something else. And that actually is here. If you look under sample, it says, if the subjects of a sample are properly selected, most of the time they should possess the same or similar characteristics as the subjects in the population. However, the information obtained from a statistical sample is said to be biased if the results from the sample of a population are radically different from the results of a census of the population. Remember, census is everyone in there. So that's why it takes so much manpower and time, because you're trying to get everybody, okay? So if it's biased, then the characteristics that you're looking for are radically different from the results of the whole group. That's what it means to be biased, okay? So I hope that helps you. Let me come back one more time to, let me switch something here. Okay, let me switch this so that we can see what we're looking at. Here's the homework. Okay, so we went over, now I told you some areas where we can use statistics. Probability is the likelihood of an event occurring, right? That we saw that on the slides. I didn't go over it, but probability is the likelihood that something occurs. We're going to study probability starting in chapter 4. So the first 3 chapters of this book, just to give you some perspective, are descriptive statistics. An introduction, it's mostly descriptive statistics throughout the first 3 chapters. Chapters 4, 5, and 6 focus on probability. So we're going to be working with that. And then after chapter 6, the rest of the chapters focus on inferential statistics, as I said. 2 areas where probability is used. Probably you don't have to think too hard. Most of us have gambled some way, either in Vegas, or you've gotten a lottery ticket, or you've entered a raffle of some kind, or you've played a game of some sort, maybe poker, maybe blackjack, something like that. So 2 areas where probability is used: gambling, any kind of gambling would use that, and also probability, you could use it in sports as well. You'll see horse racing is really popular, or even sports betting. People take what they call odds. Odds and probability are related. You know, what is the probability that the Dodgers or the Angels make the World Series? What is the probability that the Lakers trade player X to another team? Something like that. So that's areas where you might use probability, okay? Now for exercises 9 through 25, I've already shown you where the examples for descriptive versus inferential statistics are. So it's just a matter of, what are you doing with these numbers? If it's descriptive statistics, you're just going to be describing the state of whatever you're talking about. If it makes a prediction, or if it's citing a relationship, then you're going to have an inference on your hands, okay? Because of the current economy, 49% of all 18 to 34-year-olds have taken a job to pay the bill. Okay, is that making a prediction? No. Is that citing a relationship between variables? Not really. This is just a consequence. This is just telling us what percentage of people, or these people in this demographic, have taken a job to pay the bills. This is a descriptive statistic. This is a descriptive situation. Number 10 is an inferential situation. In 2025, the world population is predicted to be 8 billion people. It's a prediction. It hasn't happened yet. It's a prediction there. Okay. This is an estimate, number 12. This is still descriptive. It's an estimate, but it's not a prediction. It's just estimated. Means it's not exact. Based on a sample of 2,739 respondents, it is estimated that pet owners spent a total of $14 billion on veterinarian care for their pets. Again, descriptive, okay? Let me come down to let's look at number 18. By 2040, at least 3.5 billion people will run short of water. Take a minute, think about what you think this is. Is it descriptive or is it inferential? Remember, they describe, they organize, they summarize what we already know. Inferential statistics draw conclusions, state relationships, or state consequence. So here, this is an inferential statistic, okay? Here's another example of an inferential statistic. Look at number 22. Allergy therapy makes bees go away. Well, does it? That's a hypothetical statement. Maybe it does, maybe it doesn't. We have to test that. Allergy therapy, there's a relationship between allergy therapy and bees going away. That's an inference. There may be evidence to support it or not. Okay. So I hope that helps. I hope that clarifies for the person who asked the question. And I hope this clarifies some of the definitions. And I will speak to you in my next video. Thank you so much for coming along and watching this one. And I hope that it's been helpful to you. I will talk to you very soon. Take care, everyone. Bye for now.